So this I already maximized it, so hope you could see my screen now in full view.
Yes.
Okay, great. Right. Yeah, I think today it's more about the comparison of AWS versus Azure. I think, I think going forward we'll also add Google into this mix later. But I think this is more about comparison between these two, and I logically classified them under various categories, starting from an account to storage to virtual machine, the compute, and also the networking, and like as the logical buckets. These are the logical buckets. So, but under each of this bucket, there are a lot of products in AWS side and also on the Azure side. So this is more about a comparison of the products in this bucket under these buckets. So before that, just going to the basics, account. So how this account, the terminology of account, how is it different with AWS and Azure? And if you look at account is very basic in the world of cloud. So every product will start with some account. Like for example, if you take AWS, you will have AWS account that you create, and also in the Azure side, it's also called account. But what is the difference between these two is primarily on the if you look at on the left hand side is all AWS. In the AWS world, there'll be a lot of resources, like for example, the virtual EC2 or database or a lot of resources. All these resources will be tied to a particular account. Uh, so this account is primarily generally there'll be owner of this account, and he'll be primarily responsible to see the bill for that particular account. So, but if you compare the equivalent in the Azure world, so there's a slight change here. Account is more or less the same, but under account you have something called subscription, which is specific to Azure. Um, so typically we will have subscriptions. They uh, generally start with. Uh, Generally, they will have the subscriptions exist independently of the accounts. So and can be assigned to a new owners if required. So if and in that, if you see, you have to start with a subscription in Azure. Of course, there will be multiple subscriptions that are possible to under an account. So generally speaking, I mean logically for easy understanding. So generally there will be HR department will have subscription A, and let's say accounts department will have subscription B. So and all the billings will be based on the subscription, but again they can be tied back to an account in Azure world. So and also in the Azure world, there will be account admin who will be primary owner. He will be the administrator of this account. Generally, if you take an organization will have an account. Any enterprise you take, so this enterprise, there will be an account. Company A will have an account. Under company A, there will be a lot of departments or projects. So each project or department can have subscriptions. But yeah, all the subscriptions when it comes to billing, they all be tied to that account. So at the end, when the company A has to send or do the billing part to Microsoft, so they'll be taking the bills at account level. The billing will happen at account level. Just to add more details on the Azure side, we if you look at another comparison is that apart from the account which we see which is common in both, but in addition to that account in the Azure world has, I mean, there are other roles as well called service admin and service co-admin. So it's co-admin is nothing but similar to admin, but it's a service admin. But just that he will not have the superpowers. But so just to give a difference, like account admin, if you see here, account admin is someone who can manage the resources, which is like SQL or VM or whatever. So these are resources. In addition to that, he will be also be able to see the billing aspects as well. So that's where this account administrator is like a super user. So he can see billing also. But when you compare this account administrator with service administrator is primarily a person who can manage only the resources but not the billing. He'll be the administrator, but he will not be able to see the billing aspects. So that is what is service administrator in the Azure world. And there's a third category which is co-administrator. This guy is nothing but this guy will have full control as a SA, but he cannot change the SA. So like he can't change the SA, but service SA can add or remove CS. So that is possible, but CA can't change SA. So yeah, generally this CA will have a complete control, similar to SA. The role wise, privileges wise, it will be same. Service SA and CS are both are same, but just that CS cannot change SS because there is a hierarchy. So basically, account administrator will have SA, one SA. I mean, yeah, there's one more thing. So only one SA is allowed per subscription. So basically, there'll be if you take a subscription level, so there'll be only one account administrator. I mean, who will be outside of this account at a higher level. Under that, there'll be SA, service administrator, uh, and also there'll be only one service administrator for a subscription. But there could be multiple CAs. So that's the background. So yeah, any questions here?
We have one question. In AWS, any subscription concept is there?
There is no subscription concept, but everything is tied as an account. There is subscription concept is not there. So it is
Okay.
all everything is account. So only the hierarchy will be by account only, account ID. I mean, there will be super account at a company level, and let's say this company A, there's a HR department. HR department can have another account B, um, and there'll be HR department account C, but account B and C can be mapped to A hierarchically. But there is no subscription concept equivalent in the AWS world.
Yeah.
I have one question.
Yep.
Yeah, Murli here. Have one question. So, if you have only one account in, so he will be the super user, like an entire administrator, or do you have the hierarchy like SA and CA?
In AWS,
Yeah.
yeah, in AWS there is no SAS or CS. So it is only the account owner, and there you can create a lot of managed roles. So you can create a lot of roles, but again, that is all coming to very low level in terms of at IAM level. If you know, so it is more at an IAM level. You can classify the roles. I mean, after account, it is directly IAM level roles. So that is the hierarchy. I mean, that's how you differentiate. You create an administrator. If you remember the other sessions that we had on AWS, so in AWS we have IAM, and IAM you can create a full administrator, or you can who will have complete access on all the resources, or you can be very specific to a particular role. Let's say a person is using only virtual machines. Only you can give access only to virtual machines or the EC2 side. You can give access to EC2 only. So likewise, it will be very specific managed roles. It's again coming at IAM level. But
Okay.
but if you I'm seeing IAM as a product within. Um, but if I'm looking at a hierarchically above products, what is there? So there is no such classification equivalent to called subscription here in AWS world. There's only account owner. That's
Okay.
all, and a account owner can manage various accounts. That's all at a high level.
Okay. And then that's based on user role. Suppose, say in AWS, we have a Salesforce, which I don't have any Salesforce account. I can still access because of a single account, or that's based on managed roles, is it? Like
Yeah.
suppose I have,
After that, it's all managed roles. So it's only account. If I have to what we look at a very high level, it's all account. So, but if you
okay,
want access to any specific product or any specific service within AWS, you have to go to IAM level and then create a particular group and row users and roles. So, I mean, probably roles is what we're talking about here. So, you'll create a role there inside the IAM product.
okay, okay.
Yeah.
Thank
Is
you.
it clear?
So,
Yeah.
Sorry. Yeah, sure. This is Bala. Account administrator has the maximum permissions, right? And within that, service administrator and co-administrator will be coming. Is that so?
Yeah, correct. So account
Okay.
administrator is a superpower where he can additionally do billing also. That is a extra feature that this guy is having.
Okay.
So
Okay.
so if you have to see the capabilities or the activities that how it differentiates is account administrator can do additionally billing plus complete management of resources. When I say management, he can create, delete anything he want, he can do it. So so that is more or less common for all. I mean, accessing the resources is everyone who has full access on the products. He can all these three guys can do create, delete, manage everything. Everything they can do on the resources. Okay.
Hmm.
Uh, but the privileges extra is that account administrator will have billing, which is an additional feature which these guys will not have, SAS and CS. And SAS is this only one SA allocated to a subscription. So he can add CS, but roles wise there is no difference. So both guys have um, both guys have equal sort of full control on the resources.
Okay.
Yeah. So but another difference is that one subscription, only one SA, but many CS. That is the difference. Yeah.
Okay. And within one account, for one account administrator can then be more than one subscription
Yeah. There could be
for
more than
different
one
types of
subscription.
systems.
Yeah.
Okay.
Yeah.
Okay.
Yeah. Account is equal to enterprise. I mean, our company.
Oh,
So
okay.
there will be only one account. And under that, there will be a lot of departments. So each department can be having many subscriptions or more than one
Okay.
subscription.
Okay. So based on the usage, the billing and the resource allocations can happen based on the subscription
Exactly.
under
Yeah.
that account administrator. Okay. Thanks.
Yeah.
Thanks.
So
So
when
for any
companies,
organization,
sorry, go
for
ahead.
any
Sure.
organization, you will have only one account, right, Sham?
Yeah, correct. There's only
For
one
Azure
account.
account. But in AWS, like I said, in the current client, they have 115 accounts, and there is a product called organization, and that you could maintain hierarchy and you could have a billing control so that you could aggregate all your accounts to the central account for billing and so on. So since they didn't have the subscription, so they went little circumvent to get that feature. But Azure has this feature so that you don't have the confusion. Just keep on adding subscription to it. Have one account for the whole company. Only problem is when you have buying new companies and those kind of things, then you might have to merge the account and so on. Right, Sham?
Yeah, correct. So all this
Yeah.
AWS organization, that is a product within AWS. So that is where it is trying to, trying to bring the concept of subscription equivalent, meaning like in the form of hierarchy,
Yeah.
in the form of hierarchy. Yeah.
Yeah, that's right. Yeah.
So straight away, we are seeing how Microsoft is able to win the market from the user end. So as you rightly said before, I think Srini mentioned it, that AWS is for high-end professionals who are using it from a core technical point of view, whereas this is from a user end point to make it easier for common people.
Yeah,
E-
that is right. And they also saw it working and they improvised it. See, first time is always coming out, right? That is where the challenge.
Yeah,
Then
exactly.
copying and improving, these guys did it very well.
Right.
Yeah. I mean, there you can see. I mean, there's the 10 years of experience from AWS and all the lessons learned in this process. So yeah, I think Microsoft had understood that area well. And yeah, whatever is the drawbacks, I think it came late, so it could adopt those things in a better way.
Yeah, nicely put.
Yeah.
I think, Shyam, and when I was looking at something else, some time ago, before the test, I was looking at it, and then I learned, I think, in AWS, once you created accounts for each department, let's say sales creates its own account and HR creates an account, you cannot roll up once you create it. Though you can manage for the billing purposes and then manage the permission purposes. If you have created accounts for independent departments within the company, then you cannot roll up. I create a super account and then I make all of them as a branch under that root. Somewhere I read that isn't possible in AWS. Maybe, that was the legacy development issue that Srini mentioned. So once you create a separate account, you cannot roll it up to become the branches or the children of one mother.
There is through an organization, there is a product called organization through which you can create a hierarchy.
Oh, okay.
Yeah,
okay.
yeah. That is why they introduced that other product, because they didn't have the subscription concept. Yes.
Oh, okay. Thank you. That's good. Thanks, Srini.
Yeah.
So, Raj, we are. I don't know whether you heard the story. Basically, we are switching into multi-cloud strategy. That is why we are going deep dive into the next 2 months into the Azure. So that's what the current session we started on this. Okay.
Yes, you're having a buffet.
Yeah.
Let's enjoy. Thanks.
Yes.
Yeah.
Yeah. Okay, so this is basic. This I think this diagram should be very clear in your mind. So this because this is uh, everything when you go into the Azure. First thing is when you create a free account there. So you also see subscription created. So when you create an account as a free administrator, you're the account admin. So you I mean I you can create many subscriptions under you, and you can use it for your specific requirements. I mean, so if you have project A can use subscription A, project B can use subscription B. So you can create multiple subscriptions under the account admin. So yeah, so just you when you see this word subscription, yeah, this is what it is. I mean, that is what. Well, yeah, I know we'll see in the following session, in the next sessions. I think we'll go more into the console, Azure console, and you can see all these things in detail. Okay, with that, I'm moving to the next section, which is compute. So compute, as you know, um, virtual machines, right? I mean, it started with the journey of compute started with age old. I mean, it's not old, I would say, but still many people are still using. So it started with virtual servers or virtual machines. Then came the world of containers, and then the container orchestrators, and then the next wave is the serverless, serverless. So yeah, so if you have to classify that, the virtual servers are virtual machines. So EC2 on the AWS side is equivalent to virtual machines on the Azure side. And the batch for primarily for the batch requirements, so we use AWS batch, which is equal, it's the same name, batch. Auto scaling, primarily we want to scale up your VMs, scale down the VMs based on the load. So here equivalent is virtual machine scale sets. So yeah, this again similar, very similar to feature. I mean, it's a more like apple to apple comparison. So what are the features that you have in auto scaling? Same thing we have also here in VMSS or virtual machine scale sets. So and yeah, and this VMware is a very good. I would say this is a very good strategy that VMware is following these days. Where VMware is like before all this cloud came, VMware is so popular, right? I think it's all they have on-premise data centers. They give a lot of servers on physical servers on cloud on the data centers. But now everything is moving to cloud, and most of the enterprises are already having VMware accounts. I think now VMware made a tie-up with both AWS and Azure. So the equivalent products on the VMware side of stuff is VMware Cloud on AWS, and here VMware by Cloud Simple. So this Cloud Simple, by the way, this is another company which is acquired by Azure to bring this integration of VMware into Azure. So that's what it's called by Cloud Simple. So that it's not a homegrown product. It's a acquired product. Um, so that's and then so that's on the VMware bringing VMware accounts or VMware enterprises enterprise accounts where you can bring it to cloud, so you can use these respective products. So both these products will have VMware specific settings and other stuff. So you can use that and yeah, you can migrate your VMware stuff to cloud. And then next is the HPC level. I think it's like more of a hyper performing cloud, right? Like a lot of where you need a lot of compute, super compute, I would say. So for if you need for normal workloads, virtual machines is sufficient. But if you're talking about any like a lot of data that you want to run and you need high compute, more super compute level, like any data sets that you want to run for machine learning or all the high performance genomics based computing. So all these things you need high compute. So that's where the parallel cluster on the AWS and equivalent that is again Cycle Cloud. So yeah, so this is primarily under HPC category, the last one. Right. So that's about the virtual servers or virtual machines equivalent. And on the container world, if you come, uh, yeah, I mean, we discussed Kubernetes is always there. Elastic Kubernetes service on the AWS world, and Kubernetes service, AKS, Azure Kubernetes service. So this EKS and AKS are equivalents on the Kubernetes world. But let's say if you're not interested in or if you're not comfortable with Kubernetes, or if you don't want to, you're looking for an alternate for Kubernetes as a service orchestration tool. Uh, Other options are on the AWS world, you have something called ECS, Elastic Container Service, and the Azure it is container instances. So for example, you have a Java based or a Python based application on your that you developed and you just containerized it and want to deploy it. So your Java or Python or .NET is not it's not a binary. It is a binary is in form of a container. So then you can use but you don't want to go to the mega Kubernetes because that is bigger stuff compared to for a small simple container, simple hello world or simple application where you want to try it out, but you don't want to use the mega Kubernetes. Then if you want to be simple, take it simple, then container instances is an option in the Azure world. Similar equivalent is ECS, Elastic Container Services. So yeah, both are same. Both takes EKS and ECS. Both take containers as an input, and then you can orchestrate them. But just the difference is Kubernetes versus non-Kubernetes. That's the difference. So um, there's one variation which is missing here in the Azure side, which is Fargate. Fargate on the AWS world is a serverless component. So this is ECS is non-serverless, whereas Fargate is serverless. But there's no equivalent here in the Azure world yet. So my yet.
So
So I
this
think
is this is one of the cornerstone for AWS, serverless container orchestration. Even for Kubernetes, they have a serverless Fargate for Kubernetes. Even though Google came out with the Kubernetes, these guys are ahead in the next level of innovation. You don't have to provision the server for it and so on. Yeah, that is how this competition takes to the next level of innovation as well.
right.
So, Srini, one question, like from your experience or anybody's experience in this group, how much of this serverless is being used out there actually? What is typical use?
Yeah, it is really working very well, man, because the thing is, if you think about all these container orchestration and the nitty-gritties of details, if you go deep dive, many enterprises have hello world serverless kind of orchestration use cases only. They don't have stateful and other volume attached containers. So if you 80% of the use cases are very simple use cases, and serverless is pretty handy in those kind of things. So it is not going to solve all the problems, but it is going to solve the 80% of the problem kind of thing. Yeah.
Yeah.
Sham, do you know like any means like AWS, right? Like any examples that
Yeah. Sure.
I
Sure.
don't
I
want
can.
to deep dive.
Yeah.
Yeah, okay, that's all I need.
Sure. Yeah, I think just going to the use case. I think for very basic aspect, the difference between a serverless and a non-serverless application is basically not the non-serverless. If you take virtual machine, so virtual machine will be running. If you create a compute of a virtual machine, that virtual machine is something like your computer or laptop, which will be on cloud, and that is running for the entire day, right? And whether you use it or not, you have to pay the bill for the entire day, or for the entire year, for the if it is running for the entire year. So, but it is not. For example, if you take use cases where you have a bad job which runs for just less than 15 minutes per day, uh, but yeah, it runs only once. But yeah, you don't want to dedicate a virtual machine for it running for the whole year, right? So in that case, that's where the serverless feature will come. This primary serverless feature will help. You will give a cost optimization where on the fly for that batch job, uh, it creates a compute, meaning all the resources like how you have in laptop, right? Typically, you'll have a operating system, you have a hard disks, I mean storage. So you get everything, the networking, so everything you get it on the fly. Uh, and then once your batch job is complete, so it will dismantle everything. So that way you don't need to pay for the entire day or entire year, so for the compute resources. So it is on the fly compute. I mean, serverless is equal to on the fly compute. So on the fly you get that, and once you execute that functionality, you dismantle it. So yeah, only criteria for the serverless use cases are um, your jobs or compute requirements should not cross more than 15 minutes. So that is a baseline that is kept by all the cloud vendors. And also the one thing you need to keep in mind is that it is on the fly, so it will not be instantaneous. Like if you're looking for real time batch jobs or real time workloads, then that may not be suited because on the flight is generating, so it will take at least 2 minutes or less than that now. It is improved now, um, for you to bring all the resources up, and then only it will start executing your functionality. So it will take some time there. But I think that is drastically coming down with all the inventions around the serverless area. So that's all they call as cold start, right? So the cold start is like at the time it takes to bring this up so that it can execute your functionality. Yeah. So to come to your question, the use cases are primarily all the jobs which where you need less than 15 minutes of your compute, and it will start once and then die. So that kind of requirements is a perfect suit for a serverless world.
Oh, okay.
Did
So
I
how do
answer your
you
question?
execute? Do you have some kind of a Docker image, and then
Yeah,
you pull that? You have
exactly.
everything in the Docker, and then you execute that Docker image in a particular environment.
Exactly. Yeah. So it is exactly similar to the runtimes. I mean, so the EBS, if you remember in the AWS world, primarily there'll be the EBS is like a platform as a service, right? So you don't need to worry about anything. You just need to have your binary. The binary could be either a Docker or it could be a jar or a exe in the .NET equivalent. So it is just a binary. What it needs is a Docker or a non-Docker based binaries. So that is, and then the runtime you need to select. The runtime, when I say runtime, if it is Java application, then the Java runtime is required. With the .NET runtime, yeah, the .NET runtime, .NET, then a .NET runtime is required. Python runtime. So you need to select the runtime when you create a serverless. And then you give your jar file or a binary file or a Docker image as a reference to it, and it will execute. So it is, and you need to bother about creating a virtual machine. Creating it's a PaaS service, so you don't need to bother about it. All the logs, all the maintenance of that, everything will be managed by the cloud vendor. So, yeah,
So
for you,
only so Sham,
yeah,
one thing is we are talking two different things here. Serverless compute is called Lambda those kind of things, right? So that is one thing. Another is Fargate. This is a container orchestration. So what Sham said for is the first one. That means you need to choose the runtime. For example, if it is Python or Java or something, when you create your Lambda.
Yeah, I'm talking about, sorry, Azure
But
functions here at this point. Yeah. Yeah.
Azure functions. But when you talk about the serverless container Fargate, right? That is a next generation of like a Kubernetes itself running in the serverless node. You don't have to provision your node, but you don't have to know what kind of application it is. It's all Docker images in that time. Okay, so there are two. One is which is there for a little long time. It's called serverless compute, which is Azure and Lambda, Azure Compute Lambda, those kind of things, where the 15 minutes restriction. But the futuristic is the container orchestration itself is serverless. That is where AWS is ahead of the game. And for that, you don't have to worry about what kind of runtime. It's all Docker image. As long as you package in your Docker image, you don't even have that 15 minutes thing in that also. So it's even more powerful.
So I think just to add the point, remember we had come across their product called Fargate. So they differentiate for Docker and containers, the product called Fargate, which is different slightly than the Lambda. I think both the concepts probably are same on-demand.
Yeah, concept the same. Yeah. Correct. The Lambda is the serverless for long 5 years, 6 years, very successful. Many people are using it, right? That is what the explanation what Sham gave, kind of a thing. But this Fargate is a futuristic container orchestration itself serverless.
Yeah, I mean, just to add more there, it is the PaaS service, and there is a infrastructure as a service, right? So maybe you can Fargate is more at a infrastructure level, whereas Azure Functions or Lambdas is at a PaaS level. So when you say PaaS level, it's not just compute. Okay, so it is more than that. I mean, you get compute, you have a runtime, and that is all completely managed by the cloud. So that is at more at a PaaS level. This is more at a infrastructure IaaS level. So yeah, so that is a differentiation. So right. So and yeah, so let's move further. So I think this is all about the container compute, the container orchestration aspect. So primarily, the core products that you need to remember in the container world or container orchestration world is I think the most popular or the Kubernetes equivalents on both sides. But if you don't want to use Kubernetes, then the non-Kubernetes options are this row. So ECS on the AWS and container instances on the Azure side. And of course, both of them need a repository to store all the containers. So that is what is container registry. So it is Elastic Container Registry, and it's called container registry. I mean, just that you're familiar with it. This is the convention which I realized. I mean, just when I'm doing this comparison, most of the AWS will start with Elastic. I don't know why, but they have this Elastic as EC2 is also Elastic compute, right? Compute cloud. So yeah, this Elastic is something which is as a starting word in most of the AWS products. Yeah, just for you to know. It's a Elastic Container Registry, and this is Container Registry. So yeah, when I didn't realize when I was reading AWS only, but when I'm trying to compare it to Azure, I realized that okay, there is this is something very specific to AWS that they're adding Elastic in the head. So
And what is EC2, by the way?
EC2 is a Elastic Cloud Compute. So it is primarily for creating a virtual machine. So if you want a Windows based virtual machine or a Linux based virtual machine, you can get it using EC2. The equivalent of that is virtual machines on the Azure side.
Yeah. Oh, so that also starts with Elastic, as you said.
Yeah, correct. Yeah. Right. Okay. So yeah, sorry. The last one is I think the last. Yeah, this VMware. I think there is on the container world also there is VMware which is applicable. So, but yeah, the product is same. Server. I mean, physical server. There's no big difference. VMware Cloud on AWS. Also, you can use for container worlds. Yeah, if you have equivalents on VMware on where you already have a investment on VMware, then you can bring that to cloud on both sides. And then the last one is more at microservices. So this is a mesh concept which is getting popular, and this mesh framework is coming up where you imagine in a microservices world there will be a lot of services which will be running, and all services will be running distributed in a different compute or different servers or in different containers. So they are distributed, and yeah, so all these typical microservices problems, right? So how will you manage them? How to manage your distributed workloads running, and if one node goes, how will you manage the how will you bring it back, and all those all the learnings that are done that are there from the Kubernetes world, and there are the Kubernetes is getting popular in the microservices world, but if you look on the open source world, there is something called Consul. I don't know how much of you heard CONSUL. Consul is also an equivalent in the open source world, which is also getting a lot of popularity. And Terraform, some of you have heard of it. So it is more about making it's equivalent to dynamically generating the templates, so that it's equivalent to CloudFormation on the AWS world, where for a single virtual machine you can create a virtual machine, but if you want to do thousands of it, scripting is better, right? So you can convert that to a template, the one virtual machine, and convert that to a template, and which will be JSON format, and use that for your yeah, for generating 100 resources on the fly. So yeah, so that that is again AWS specific, and also there is a Azure equivalent is also there. So, but all these things are going cloud specific. But people, yeah, generally enterprise, they don't want to go very cloud specific. So that way, I mean, it is like you're tied to the cloud, right? So the open source world is also equally getting popular. So uh, so that's why this Kubernetes is one good start, where it is completely outside cloud and completely managed, where all the cloud vendors are equally participating in the development. But apart from Kubernetes, for smaller workloads, uh, console is also equivalent in that world, and the console is equivalent to service, is equivalent to Kubernetes, but when multiple orchestration tools are coming, so they want to build a wrapper on top of all the Kubernetes equivalents. So that is what is app mesh or a mesh. It's a mesh framework. So the mesh framework is like Kubernetes is a orchestration of containers. Okay, mesh is orchestration of container orchestrators. So you can relate that way. So it's not 100% that, but you can for quick understanding, you can relate that. So for example,
can you repeat that? Can you repeat that, please?
yeah, I mean, Kubernetes is a container orchestrator. Okay, but imagine there is Kubernetes and there's something else called Consul, so which is on the open source world. So both are container orchestrators, right? So, but you want something a layer on top where you want to use both at organization level, Kubernetes plus Consul. So you want something one layer, an orchestrator above this container orchestrators. So that is what is mesh. So it's called managing multiple Kubernetes equivalents. I mean, if you have to simply relate it, put it in one word. So yeah, I
Yeah.
think
So
it's all more going. Yeah.
yeah, one thing is in the microservices world, see the service mesh pattern, that is basically to see across the service mesh how the traffic is being routed, they want to see the visibility, those kind of things. That's one of the way the mesh is basically used. Even in AWS, they have a mesh. Istio is one of the mesh. So the thing is, instead of confusing, probably we should have a separate slide later to talk about. I like your idea of having a, see, now we are talking multi-cloud, right? And also cloud agnostic. So we'll try to put together some point, not immediately, at some point later, the comparing. So for example, cloud formation is for AWS and they have their proprietary tool for Azure. Terraform is for the cloud agnostic way of making the same things happening. Like that for every of these layers. I think what I'm trying to say is, it might confuse people because we'll try to have a slide and we'll think through on this. It's a discussion by itself. It's a deep dive.
Yeah, I think we
Okay.
definitely it requires a deep dive.
So
Yeah.
Sham. I have used console, right? Like, so, but that use case is very specific, right? Like, I'll give you a little bit of difference of how we used it. Kubernetes, right, knows that it has to. So let's say you want 3 containers, like let's say for fault tolerance, right? Let's say we want 3 containers. It'll create 3 containers, but all the 3 containers are going to be active. And it is going to load balance. Like basically there is some load balancer where based on the traffic, it will route to the container. Like, so if one of the container goes down, Kubernetes knows, oh, okay, I have to keep 3 minimum. So let's bring up another one, right? So there is no kind of a active passive thing in there. Kubernetes doesn't know that. Console comes in, there it can register, like, and you can tell this container is going to be my primary. And if that goes down, the next in line is going to become the primary, and and I'll bring up the other one actually, right? And Kubernetes brings up the other one. So it is, that is the way. And of course, service mesh is a little higher concept, but this is one of the use cases that we have used console. And it's it may be orchestrator at the level, but the orchestration is at a level of like you have a fault tolerant service available, right? Basically, Kubernetes doesn't do that. It knows how to maintain the load or like the number of active participants out there. Like if you want 3, it will keep 3, and if one goes down, it will try to bring up the third one again. So that's the difference.
Yeah, exactly. Yeah, I think I think we'll definitely we should have a session deep dive in that. So I think that's a good explanation. Like good that we have people with console background in this team. So I think the console started their journey even before Kubernetes came. So, but yeah, just that Kubernetes picked up so well, and it yeah, it's all Google's promotion and thanks to Google's promotion, and yeah, it was very, very well adopted. But as a next level, once people started using Kubernetes, they realized more problems in Kubernetes, which when we're talking about a mega load and managing that is even more difficult. So, and especially the microservices brings more new problems into the system. So yeah, so to address all those things, I think this mesh concept has come. So I think the Istio is one popular open source equivalent of similar to App Mesh or Service Fabric Mesh. Istio is equivalent in the open source world like Kubernetes. Yeah, and yeah, let's discuss that in a separate session. So yeah, but yeah, any questions in this compute? And yeah, sorry, I didn't mention that serverless. I think
Only thing is, let everybody goes to mute, please, so that way, yeah, we could hear only one voice. Thanks.
Yeah, Shyam, actually, I have one question regarding the forget. So the forget concept is, you talk about AKS alone, it is there already in Azure.
The forget is with AWS. AWS serverless way of orchestrating the container. You don't have to provision your, usually for container, you have to provision your EC2 machines. But here, when you say it's a forget, it creates it actually creates the EC2 not on your account. It creates the EC2 on the Amazon account. So all these things, right? For example, the serverless, you think it is some magic, but it is not. It is not on your account, but it is happening on the AWS account. That is the only restriction, only difference. If it is running on your account, you will be paying. But if it is, since it is happening on their account, they know when to start and when to stop because it's serverless. So that is why you pay less and they maintain it.
Yeah, thank you. But this concept is equivalent for Azure.
No, there is nothing in Azure fold. Even in Google also, they haven't come out with this serverless thing yet. He, so he just put both here.
Yeah,
ECS is equivalent to container instance, but there is nothing for forget on the Azure side.
yeah. The serverless, I think what maybe the word serverless is a bit confusing in where it is applied. So in Azure there is a serverless equivalent called Azure Functions. Okay, so this is a serverless component in the Azure world, but this is a PaaS service. Okay, so just that be more clear. So this is more of a PaaS service, which is serverless component in the Azure world. But if you take only compute, but yeah, there is no equivalent yet in the compute world in the Azure side. That's what I'm telling. So serverless as a feature is available as in the form of Azure Functions but
Yeah,
it is
yeah,
more a
as
PaaS
a
service.
subscription based
Yeah,
service.
it's a
Yeah.
PaaS service, right? So it's yeah. Okay, so is it clear? Move on to the next section. Okay, yeah. Next, come to the database. Uh, database. I would say here, in fact, AWS is leading the way. Just that in terms of the number of databases that AWS has, I think it's one of the leading vendor in compared to any cloud. I mean, even Google also. So yeah, but anyway, with the data, I mean, with the equivalence what we have, others can go on mute if someone is not talking. Okay. So in the if you do a comparison of the database world, so the logical classification again, relation database, caching, and a NoSQL or a document DB equivalence, and then of course this is a separate set, but related database migration. So that is, I don't know who is that. I think people go on mute, please.
Murali, I think you can go for mute. I think that's what.
Oh, I'm sorry. I'm sorry. I'm sorry.
Okay. Right. Yeah, so in the database world, if you see the relational database, RDS, which is it is a one product for all relational databases. So it is like consolidated everything into one product in the AWS world. It's called RDS. But if you look at an Azure, it is we have specific products. If it is SQL database, it's like more SQL Server. Then on the open source equivalents, MySQL and Postgre. So here all these things like database for MySQL, database for Postgre. So this is the equivalents. But if you look at on the AWS, RDS additionally supports two more databases, which is Oracle. Apart from these three, SQL Server, MySQL, Postgre, RDS also additionally supports Oracle and MariaDB. So these two are additions. Maybe it will feature definitely it will come here in this Azure world also, but it is not there yet. Um, yeah, so this is that's one difference. So RDS is a group of many databases in one product. So but here it is very specific to each database, right? So that's on the relation database side. If you come to the non-relational, which is the NoSQL or the document equivalents, so we have various databases here specific to the functionality. Dynamo in the AWS world, it is DynamoDB, SimpleDB, and DocumentDB. All have different use cases. So DynamoDB is a NoSQL database, primarily key value pair combination. SimpleDB is it's just a JSON based structure. and document DB is more document specific, the document format structure. So they have the NoSQL has a lot of variations generally, right? So the key value way of databases, the document databases. So likewise, there are a lot of classifications under NoSQL. So we have separate product in each of these areas. But here on the Azure side, they have they're yet to release an equivalence here, but what they are promoting is Cosmos DB. So Cosmos DB is like is a multi NoSQL features all embedded into one kind of a database. Like you can do all these things in one DB itself, basically similar to RDS, where in one RDS you can do multiple databases. Similar to that, they try to bring that model in the NoSQL equivalent. So yeah, that is their betting point. Or if you go to Azure, they promote. If you're looking for DB, they promote more on Cosmos. Because that's their own homegrown solution, and it is similar, like a multi-primary, multi-replication, multi-region support, all these things, all the popular feature for a high availability stuff, everything is inbuilt into the system. So it is like all the inventions are put into one basket. So that is Cosmos DB on the database side. So you get better performance and all those things. So yeah, so that is on the Azure equivalent. We come to the caching world. Caching is more, as you know, it is before going to database. If you want to improve let's say if you have more reads to your requirements, and you want to cache the data before going to the database, so that way next time when a new request is coming, it will not go to the database. Instead, the cache will fetch you the results. So that way your performance is more faster, and trying to reduce the load on the database. So that's more about it is not a database, but it is equivalent to it also stores the data. So that's how it is comes under database category, but it's not exactly a database. So it is just a cached data. Not you'll not be able to do uh, all the all the operations like how you do in the database. So it's not a real database. It's just a data store. That's all. So yeah. So in that category, Elastic Cache is the AWS equivalent. On the Azure equivalent, it is Cache for Redis. So if you remember in the Elastic Cache, this has two sub features in this. In the AWS world, it is Redis based cache, which is equivalent to this. But before Redis was introduced, they had memcached, memcached, mem cached. Sorry, just I'm trying to type the name. So memcached. So this is what is used. This also has an additional feature in the Elastic Cache. So basically, Elastic Cache in AWS world supports Redis plus memcached. So you have option to select this or that. Uh, but yeah, but just that memcache is not suitable for an enterprise level, or if the data is more than Redis is a better option. Again, Redis is something an open source implementation. Plus there is a company behind as well, Redis. But yeah, so that is become more popular for caching requirements in the open source world. That's how both the vendors have implemented Redis equivalents in their caching system. So yeah, so Azure you have cache for Redis. In AWS it is Elastic Cache. Again, Elastic is the keyword here, right? And then database migration category. It's not a real database, but yeah, it's more about migrating your data from on-premise to cloud. So in that category, so you have database migration. So both names are same in both sides. So AWS migration service. So it's a database migration service. So this is yeah, the same name. So where you can migrate on-premise. I mean, it's all homogeneous and heterogeneous combinations. Both support homogeneous, heterogeneous. What I mean by that is like on-premise to cloud. So that is what I was talking about. The very common use case. But in addition to that, it can also let's say you're already in cloud. but you want to move from database A to database B. So that's more of a heterogeneous combination. So heterogeneous is like migrating from Oracle to SQL Server in cloud. So that's a heterogeneous combination. So yeah, both of them support that, but I think Azure has to pick up there. It is not all databases supported, but AWS is leading in this space. They support all the along with RDS, considering that they're supporting more databases in this layer. The database migration services also support multiple databases like MySQL, Postgres, MariaDB, SQL Server, Oracle Server. So all of them are supported now. Yeah, well, one since we're talking about the database side, I think one news that I heard recently, which is like again not very new, like 6 to 8 months old news, that Oracle is now tying up with Azure. So, meaning Oracle is having a partnership with Azure. I know most of you might be knowing it. Like there's a generally in the open public itself, there is a war always between AWS and Oracle. Uh, so yeah, so that is in all the reInvent sessions also you can see that. In the official presentations itself, they will compare with Oracle. AWS will compare with Oracle, where they say AWS is growing and Oracle is dying. So yeah, maybe that could be one reason. But Oracle preferred uh, Azure as a partner for their database support and database migration. I was listening this in the podcast today that they're trying to bring. Like if you take enterprise requirements, apart Oracle is more famous for databases, Oracle database, but apart from that, they have a lot of other things on the also on the SAP equivalent, sorry, not SAP equivalent, so JD Edwards and PeopleSoft and all those softwares, SaaS services. So those services, if people who are already using Azure, so they want to do the migrations and uh, from that support aspect, they're looking for a part. They came with a partnership where they with Azure, you can bring all this JD Edwards and all those stuff into Azure, and also most of them are on-premise softwares. All these solutions are on-premise software, so we can also bring the on-premise data on the Oracle side. All these Oracle products, SaaS products, you can bring to Azure using the on-premise, on-premise offshore hybrid model products like where you want to pull the data on in private network. So you can do all those things because of this partnership. And they are also forming a dedicated support group where if any issues are there in this data transfer between data center in Oracle to Azure, so they were like whom to contact. So is it Azure to contact or Oracle to contact? So they formed a separate support team. People with the team will have knowledge on both Oracle side. Oracle also has a cloud, right? So most of you know it. So Oracle is having a cloud. But it's not popular yet. But yeah, I think so. They also promote a lot of products on the cloud side. So this partnership is trying to bring most of the common issues that we face in the real time, and when they do migrate from Oracle Cloud to Azure Cloud or Azure Cloud to Oracle Cloud or Azure to on-premise Oracle servers or racks. So all these combinations are covered in this partnership primarily. Yeah. Just since we're talking about database, I just recollected that, so sort of sharing that aspect. So yeah, I think let's move to the messaging. Sorry, any questions here?
Yeah, I just wanted to add, maybe you didn't, you overlooked this one, like Azure has this, because that's my area of
Yeah, go ahead,
specialization,
please. Yeah.
which is the Azure's data warehouse, SQL data warehouse, which is now called Azure Analytics. It's for the multi-dimensional OLAP. In the on-premise world, it used to be SSAs, Analytics Services Cubes, right? Now
Yes.
you
I
have
have a
this.
separate section for analytics, so that's why it will coming there. It is just pure
Okay.
database
Yeah,
section.
that.
Yeah.
Okay. Then
Like
that bit. Data
Sorry,
blob
Shyam.
storage
Like,
and data bricks, right? Those
Yeah,
three
exactly.
will be
That is
covered.
correct.
Okay,
Yeah.
thank you. Sorry about that. Yeah.
Yeah.
sorry, Shyam. Like, are we not comparing Redshift with Azure Synapse here?
Yeah, sorry, just to differentiate, I think this is database only. I mean, so this is a separate
Oh, okay.
section called data warehouse that is coming,
Oh,
or
okay. That's fine.
analytics.
Okay.
Yeah.
Shyam, currently, if the source data is in Oracle, Azure does not have a solution. Is that what we are saying?
Uh,
That is, Oracle cannot be moved into Azure.
yeah, that is, there is no separate, yet there is, I think this partnership is primarily meant to bring that into the Azure. So I think it is
Oh,
still on the way.
okay.
Yeah, it
Yeah.
is not an official product yet for Oracle.
Okay. Yeah. Okay. Fine. And regarding
Yeah,
this
if you,
elastic cache, is 1 second. So just I will quickly finish this. Elastic cache and the cache for Redis. Are these a different hardware itself? Because it is
No,
about
it's
cache
completely
memory, is it a
different
different hardware or is it only there is a software?
software only.
Okay. Behind that is still only EC2 kind of storage, or is it a different set of
No,
hardware?
mostly this will have it's a software and it talks to software only, which is database primarily. So typically in a typical caching world, so typically you'll have a cache system.
Right.
Then this cache will talk to a DB. Is the most common use case. For example,
Oh,
an API, which is generally want to talk to database. Uh, and to reduce the load on the database, we bring cache before database. Um,
okay.
so this cache is software again, and database also software. So when any API request comes, so if the data for that API is already there in the cache, it will not go to database. It will try to give the feedback from here. So for
Correct.
cache
Yeah.
itself
But
will
if
give the
both
feedback.
the
Yeah.
database and the cache are from the same hardware, and if the response time are the same, why use cache? In that case, probably it can directly fetch it from the database. So probably there should be some improvement on somewhere using the cache, right? So that is why I came to. That is a normal concept that we have it in our normal PCs itself, right? So whether I just wanted to know whether is that the concept or it is just a pure software product. That's all.
CR, definitely the response time for cache is going to be way better than database. There is no hands down, it is that actually.
Right.
So the thing is, like, if you are going to repetitively read a certain data from a database, why go
Okay.
to the database every time? You
Right.
keep it in the cache, and then the response time is going to be really fast. So, and yeah, but what he showed is the exact typical use case actually, right? Like,
Correct.
so most of the times the applications are just reading the same amount of data, or like nearly the same. Means if you take a thing, 80% of the time it is the same data that's reloading or using the other means related data. That's it. So if
Mhm.
you know that what is going to be read, you can load it up into the cache, and then the application is going to be really fast. So that's the reason why we use employee cache. And I don't think there is any means there is something called pass through and other things where you read through the cache actually, but the cache you hide it. You think you are reading from the cache, but it might be fetching some data from database. That's all advanced concepts, but basically keeping it in memory versus keeping it in disk, which is faster. So
Yeah,
memory
exactly.
is much faster. So cache is equivalent to the
That's what
memory. Yeah. And
exactly
then
my
disk
question
is
was.
like
Yes,
database.
that's what,
Yeah.
because the memory and the database are not made up of the same hardware. So that's what usually that was the base of my question.
Yes, I think yeah. I mean, if you talk, this is a VM. So this database, if you're looking at the managed services, we don't know what is behind. But if you're doing your own, setting up your own database on a virtual machine, so you can. This is a virtual machine.
Oh,
Generally, it
okay.
will be a virtual machine. Database will be a
Yeah,
virtual machine.
right,
This is also a
right.
virtual machine, but just that it is both. It primarily uses more of in-memory way of storing it, and storing the data is in memory. But this is
Okay,
more a disk. Finally, the data will be stored. Database will store this stuff in a disk
exactly.
eventually.
Oh,
So
okay,
there is always like fetching, going to database, writing it, and whenever you want to read from a database, it will go and fetch again from the disk. So there's always a the IO aspect which
Time
comes
lag.
there.
Yeah,
So
time lag. Yeah, right.
yeah,
Okay.
so but that can be this IO problems can be restricted. It can be avoided
Right.
here because it's in memory.
Yeah, that's what Jan has said, that mostly it is 80% of the requests are repetitive, so it can directly fetch it from the cache memory itself.
Exactly.
Okay.
Yeah. Yeah.
Okay.
Yeah.
Thanks.
It's again more about the performance aspect. So just to let's say
Right.
a very common use case are that your API load is high, then your database also you need to take care to
Correct.
manage that load.
Correct.
So the typical common use cases are for if you're read heavy data scenario, then it's always good to use cache before a DB. But if it is not read specific, it's more writes. Then yeah, this will not help you much.
Correct.
Yeah,
Agreed.
yeah,
Yeah. Okay. Yeah. Thanks.
right. Okay. Uh, right. I'm. This is a separate section coming on the data warehouse side. So yeah. So I think you'll see it in the following slides. So typically, yeah. Now we're moving to the messaging aspect.
Sure. This is another quick question. So before you go there, right? Like, so do
Yeah.
you want to do you want to talk briefly about Athena, how it plays a role in accessing the data in relational databases, or just from a AWS side?
Yeah. Sure. Athena is primarily yeah. So primarily Athena's role is where we are talking about unstructured data, which is primarily we use S3, which is your storage layer in the object storage world of AWS. I'm talking about AWS now. So in object storage category, we have something called S3, which is more popular, where generally we store all your images, your files, everything. It's like a hard disk on cloud. So, but just it is object-based storage. So, HTMLs, PDFs, all these things you store it here. Um, so the problem with this is that S3 doesn't have a proper search facility. I mean, it is improving, but still there is. I mean, I'm talking about going back to the world before Athena came. So there is no proper search on S3. So that is missing. I mean, you have to go through. There's no SQL way of doing it. To be more specific, so a very common filter is that you have a lot of files. Then you want to retrieve a specific file. So you have to physically navigate through all the subfolders and try to get that file. So, but imagine that this is backed by an SQL query. So then you can easily retrieve the specific file with an SQL query, right? So that is where this Athena plays a major role. So Athena is nothing but an SQL for object storage. One-liner if I have to tell this. So it's more you can do a select star from bucket. So sorry, yeah, I can write the typical SQL way. Select star from the bucket name. Bucket name is nothing but a folder, a root folder in the S3 world. So and then you can apply a where condition here and typical SQL way of filtering stuff. So where bucket name is equal to this and then subfolder level is this. So you can do all this stuff there. So yeah. So that's more about Athena is more about SQL for object storage. If I had to put in one line.
Thank
So
you.
is it so? Can we say that the equivalent is that Azure Blob Storage in Azure environment, right? The Azure Blob Storage, which
Yeah,
stores.
that is S3 equivalent is Azure Blob Storage, but
Okay.
Athena is more SQL on blob storage. So that is the difference. So blob storage is this. I mean, AWS world. Uh, uh, yeah. So S3 is blob storage in the Azure world. So you can
Okay.
store content,
Okay.
but I'm talking about retrieving the content in the form of SQL. So that is what is Athena.
Okay.
I think that is
Okay.
at least. As far as I know, there is no equivalent yet in the Azure world on this.
But Databricks is that
Yeah,
Spark
Databricks
and stuff.
is more a Spark based. I think that is more. Yeah, I think that is equivalent. I would say, but it is. Yeah, I think this tool is. I think Databricks is more bringing many things inside one bucket. Like it is Spark based solution for
Yeah.
where you can retrieve using Spark queries. You can bring stuff. So, but it is. maybe, but but if you look at this is not Spark. I mean, this is pure SQL query. I mean, it's not even
Oh,
Spark. You need to know all the Spark concepts. It is not
okay,
at all on
okay.
Apache Spark concepts. So it is completely pure SQL.
Okay. First time I'm hearing what is Athena. Is it an open source or what?
It is not open source. It is AWS
Oh,
proprietary.
oh, I see. Okay. Okay.
It
Thank you.
is
Thank you.
an SQL for retrieving something from your object storage. So I mean, here it is S3. S3 is AWS World Object Storage. Again, this is an AWS product. I mean, just to be more specific, it's not open source. Athena is an AWS product.
Okay. Thank you. Thank you.
Yeah. Yeah. So I think the alternate. I mean, since there is no equivalent to this yet, but there's a roundabout solution for this in the Azure world, which is Databricks. So where using Spark based implementation, you can bring the unstructured data also you can query. So that is a solution. But the Databricks is not just meant for that. It is like it is bringing it is more or less will come under the big data category where you can it is more like you can do structured unstructured it's more of data lake mixed combination data lake category is where this database comes like in database sorry data lake plus Hadoop also not Hadoop the Spark database data lake plus Spark is what is Databricks. But yeah, that is a
Uh,
more at a big data level. But there are equivalent in the EMR is equivalent to Databricks
oh,
in this world. But yeah, but this is very simple. I mean this is pure SQL only, not for big data requirements. It's pure querying some from assuming that you have a files on your Windows server, Windows machine. So you have files somewhere in C drive. Imagine that you have a simple SQL query using which you can retrieve a file from C temp folder. You can retrieve a file. So this as simple as that. So that is Athena. Okay,
I know
sorry.
I know there's something called USQL. I don't know what that is in the Azure world, but maybe I'll leave it to you to
What is that?
explain
What is that?
later on. USQL.
SQL. Okay, I've not
Yeah,
heard of it.
there's
Yeah,
something in that's
yeah.
something in. I think it's for big data query. Maybe that's. I
Okay,
think
okay,
so. I'm not sure.
okay,
There exists one.
okay, okay. Yeah, I will take a look. So I'm not aware. Okay, that's good. I think good that we are discussing on other aspects also in this. So I think we are running short of time. So maybe I think I'll
Yeah,
quickly
for the
complete this
sake of
messaging
timing,
aspect maybe.
yeah, probably with messaging we can finish today, right?
Yeah,
Because
yeah.
uh,
Okay, and this messaging is from the name itself. We can say if you want to notify someone for on any event that is coming. So I mean, the open source world, Kafka or Pulsar will come under this category. But on the equivalents for that in the cloud world is a queuing service, which is simple queue service, and in Azure world it is queue storage that is equivalent. But here there is a additional product in the same category in Azure, which is Service Bus. So again, the difference is that queue storage is simple queue service. It is just similar to um, uh, Kafka or Pulsar, where it is purely meant for only queuing service. Uh, but the service bus is a bit extension to that functionality where you can also talk to other Azure products. Like it has an integration with the other Azure products as well. So so that is a add-on on top of this. So let's say you want to it has a lot of handlers using which you can talk to other Azure products. For example, it could be the source could be one system and destination could be one system, but the source will have a lot of handlers, destination will have a lot of handlers, which will talk to other AWS, other Azure products, for example. So that integration is what is an additional advantage. But if you're not looking for such integrations, then you're looking for simple queue solutions. then the queue storage is a solution. But in the AWS world, it's only SQS, which is common for addressing both these things. And then this is all about queuing. So where all the messages that is coming will be stored in the queue, and the first in first out rules are applied. The messages coming first will be served first. So that is the queuing system. But if you're looking not just queuing, but also you're looking for a notification. And the notifications are based on the events. Then so which means we're talking about here the multiple producers and multiple consumers here, and consumer can subscribe for on a topic similar to the Kafka or Pulsar equivalents. So that then this so it's not just queuing there. It is queuing concept is there. In addition to that, there will be multiple producers, multiple consumers, and consumers can register to the broker. So that way, if there is any change in the producer, so we have to put it in diagram is more better. So producer, so there will be something called your core system, core engine, or they call it in open source they call it broker, and then there is a consumer. So this producer can be an application A, this consumer can be application B. But this consumer is waiting for some event that is coming out of from application A. So the application A will send that event to this core engine, and he will forget, and he will continue with his activity. Now this consumer who is registered to the broker will automatically get that information, so that he can take some actions based on that. It's a typical event-based system. So producer is generating an event and pushing it to broker, and then he is continuing with it. And consumer is now, since he registered to that event, he will get that event and he can take some action based on. So both are independent now. This application A and application B are independent now. So to be similar, best example is WhatsApp. Like WhatsApp, you send a message to WhatsApp. On the other side, whenever this guy is free, he will see. If he is busy, he will check later. So it's more asynchronous, right? They're not tightly coupled. So that is similar concept. So yeah, that is what is this messaging aspect. So yeah, so in that simple notification service, and the equivalent is event grid on the Azure side. Right? I think any questions here?
I have a question.
Yeah.
Is this sorry, I'm not expert in this one. Is this that on-premise equivalent of those TIBCO and MSFQ middleware software, or these are the middleware thing in on-premise world?
Yeah, it is similar to the middleware. Yeah. So MQ, right? TIBCO, MQ, those kind of thing. That's equivalent cloud thing. Yes.
Okay. Thank you.
Yeah. So I think in the open source world, it's something called, of course, RabbitMQ is also there, and yeah, a lot of IBM products are also there. A lot of IBM MQ products. Yeah, TIBCO is also one such. So yeah, there's a lot of proprietary and custom developments are there. Yeah.
So,
Right.
Yeah. So for the sake of time, I think we kind of started with this Azure venture, right? So we will go a little deep dive going forward. That's the primary objective of the next 3 months thing. But we'll try to compare AWS wherever possible. And today, since we talked about 30 minutes initially, we didn't have deep dive. So going forward, probably last 15 minutes or something, we'll go for deep dive AWS discussion for whoever wants to have. So probably we'll wind up 11:15 with the Azure and last 15 minutes for general discussions, probably. Any suggestions? Yeah, let us know how that goes. Okay, so that's what we are thinking currently.
Yes. Yeah. One request is that maybe give us more feedback so that we can try to fix them in the following sessions. I think feedbacks will help, so that way we can improve upon.
Yeah, this was great. Thank you so much. I think the going forward, the multi-cloud discussion is an apt term for our group. I really like it. Thank you so much for all the time you're spending, Shams, Srini, and other members who are chipping in. I really like this. Thank you very much.
Thank you, guys.
Yep. Thank you. Appreciate it.
Thank you.
Yeah. Thank you.
Thank you. Bye-bye.
Thank you.
Thank you all.
Thank you.
Thank you, guys. Bye.
One question, can you share those slides, please, later on? Can you share the
Sure,
slides
sure.
in the group email?
Yes, I will send it in the. I'll upload it to Google Drive, and I will give access. I think everyone, most of you already have access to the Google Drive. In case someone is not having access, let me know. I will add.
Okay, I haven't accessed it yet. I will try it. If I'm not, I'll ask you. Thank you so
Sure.
much.
Yeah. Okay. Thank you. Bye-bye.
Thanks, guys. Have a good day.